In this example, we will anti-differentiate x times secant squared x. Note this is something that is ideal for an application of integration by parts. You have x multiplied by a function, and that function is being multiplied by something we can easily anti-differentiate. So let's go ahead and do so. So if we let u be equal to x, and dv is secant squared. So v is the antiderivative of secant squared, which is tangent, and du is dx. So integration by parts tells us that this is equal to uv, so x tangent x, minus the antiderivative of v du, so minus the antiderivative of tangent of x. Now the antiderivative of tangent of x was one of the practice problems in the section on substitution. But let's go ahead and go through those steps again. So if you wanted to differentiate tangent, the thing to do would be to write it in terms of sines and cosines and use the quotient rule. Similarly, if we want to anti-differentiate tangent, we write it in terms of sines and cosines. And then we apply a u substitution. And the u substitution that would be appropriate here is to let u be what's inside some other function. So I'm going to say w is equal to cosine, so that dw is minus sine x dx. So we have the x tangent x portion. And then go ahead and think of this minus sign as being inside the integral, so that in the numerator we have minus sine x dx, which is going to be our dw, and we're dividing by cosine x, which is w. So x tangent x plus the natural log of w plus c, and our last step is to resubstitute back in. So w is simply cosine of x. So kind of a big picture overview here. If we have a function we would like to anti-differentiate, which is of the form x times a function, if that function is something that you can easily anti-differentiate to go from, say, dv to v, it makes a good candidate for integration by parts.